Okay, so let's look at number 14. We have a football kicker who's about to attempt a field goal from the 30-yard line. Okay, so the football kicker is right here. Oops, let me do that a little bit smaller. So right here is a football kicker. And he is lined up directly in front of the left goal post. So if you look at this, right in front of the left goal post is where he's lined up. And then it says, but since there is a wind coming from the right, okay, so here's that wind coming from the right, so it's from right to left, side of the field, the kicker aims for the right goal post. Okay, so he's aiming for the other goal post is where he's aiming. Okay. This means that from above, the ball will be kicked at a 79-degree angle to the 30-yard line. Okay, so we've been saying it all this unit that kind of revolves around U right there as far as the origin. And sure enough, from 0 degrees all the way to where the kicker is aiming, that is creating this 79-degree angle at that 30-yard line. Okay? It says the player kicks the ball at this angle with enough force to make the ball go 47 miles per hour. Okay? So 47 miles per hour, you could say, is that strength, otherwise the magnitude of his vector. And it says, and the wind is blowing at 10 miles an hour. Use a vector sum of these two forces to show that under these circumstances, the kicker will miss the actual field goal. So you're trying to show that that kicker is going to miss. So let's go ahead and build a quick little table. Okay, we have K for the kicker. We have W for the wind. And let's see what we're going to get here as far as a resultant vector sum. Okay, so we have directional angle, we have the magnitude, and then over here we're going to have K plus W, otherwise that resultant that we're going to get. So let's go ahead and put that just in black to show that there are different vectors. Alright, so the kicker is going to kick with this 47 miles per hour, so that will go here, and the kicker is kicking at 79 degrees from that 30-yard line. The wind is blowing from the right to the left, so that is 180 degrees, whoops, right here, of what that of what that wind is traveling at. And the strength, otherwise the magnitude of the wind, is in fact 10 miles per hour. So we're going to get these xy components by doing what is 47 times the cosine to get the x, and what is 47 times the sine to get the y value as far as the vectors are concerned. Okay, so let's go ahead and go to our calculator real quick and see what those will give us. Alright? Okay, so we have 47 times the cosine of 79 degrees. 79, oops, I have to change this to the mode of degrees and then make it my default. And then let's go back and try that again. Okay, so 8.968. So 8.968. And then we're going to do 47 times the sine and see what we get there. So 47 times the sine of 79 degrees, and we get 46.136. So 46.136. So, little FYI. If you're trying to make the goalpost, okay, not only do you have to travel this 30 yards from the 30-yard line to the end zone, each end zone, just in case you didn't know, is 10 yards also itself. So what this person actually has to end up kicking the ball is a total of past 40 yards. Okay, so again, 30 yards will get you to the end zone, but then to get to the field goal, you have to kick it this additional 10, so that the total is at least 40 yards straight. So it definitely looks like the leg is there because this person's kicking it at that y value of 46, which is 6 yards more than what is needed. Alright, so far so good on that. Let's look at the winds vector. We're going to do 10 times the cosine and 10 times the sine of 180. So we see 10 times the cosine of 180, 10 times the sine of 180, and we get negative 10, 0 for the winds vector. And then just adding straight down the way we've done all unit with vector addition to get k plus w, the resultant vector, we will do the 8.9 added with this negative 10. So let's go ahead and go back up into our calculator. And we're going to add that negative 10. And we get a negative 1. So a negative 1.032 is what it rounds to. And now we're going to add the 46 and the 0. So we get 46,136. Okay? So this is our resultant vector. Very, very, very important. And if you remember from class, it's very important to see what are the signs of those components. Because if I have a negative x and a positive y, what I'm basically saying is negative x and positive y could be in the second vector. So somewhere in this second vector is where I'm actually going to end up kicking the ball because the wind is acting on it. So already you can tell somewhere, so let me make this a little bit more predominant. Here is where the person is lined up. And if they're kicking the ball somewhere into the second quadrant, they're already going to miss that field goal because it's going to be to the left of that goal post that they're lined up right in front of. So if it was a perfect 90 degree, it would hit the goal post and pop or bounce backward and still miss. But this is going to miss even more because it's saying with the negative x positive y that it's going to result into that second quadrant. Alright, so let's keep going because it says use a vector sum of the two forces to show that under the circumstances the kicker will miss the field goal. So in case you were not already convinced merely by this resultant vector, you can do the arctangent of the y over the x and see what directional angle it's actually going to do. Now remember, because we're in quadrant 2, like we would do also in quadrant 3, we're going to add 180 to whatever it is that we get here, just like we would do if we're in this quadrant. Okay? Remember, if we're in the first or fourth, we don't do anything. We just write exactly what you see from the calculator. So let's go ahead and do that. We have arctangent of this y value of 46.136 over the x value of negative 1.032. And you get a negative 88, which we're going to add that 180 because it's in quadrant 2. And you get 91.281. So 91.281 is in fact the directional angle that that's going to be traveling at. So if here's 0 degrees and we go here to 90, 91 is going to be pretty much where we sketched our vector to be right there. So that total is going to be 91.281 degrees. Okay, so then again, it's showing you right there with that angle even so that it's going to miss the goal. It's going to travel just to the left of the goal and it's going to miss it. And if we do the magnitude, if we did the magnitude of this resultant, we're just going to do the square root of the squares. So the square root of the sum of the squares. So here we go. The square root of parentheses, negative 1.032. And we're going to square it and then add it to the square of the other one, which is 46.136. 46.136 squared, and we get that the magnitude is 46.148 is what it rounds up to. So it definitely has the leg because it went, all it needed to travel was 40 yards, and now it's traveling 46. But it's off. It's traveling at a wrong angle and in this vector as well. Okay, so a little extra stuff that I wanted to show you. Those of you who I'm going to allow you to use this program to, in fact, check your answers. This is how you would use it for this particular problem. Alright, so you'd press vars, you'd go to vector, and all these programs are not going to be on there for you. There's just going to be one program, and it's going to be called vector. And you have two vectors, so you put a 2 in there and press enter. Whoops. Let's hold on just a bit. So we're going to say vars, we're going to say vector, and then we'll press enter. just like that. We don't have to put the 2 in. Because then it asks us, how many vectors do you have? Well, you're going to press 2 and then press enter. And then you got to ask yourself, did this problem deal with bearings or did it deal with directional angles? Okay. Now this one is not a ships or planes kind of problem, so it's not bearings. So on the calculator, we're going to press 2 for direction. And now we're going to press the magnitude. Okay, so what I'm inputting now are the magnitude and then the angle. Okay, so let's go back to the calculator, and the magnitude is 47. Okay, and then the other one is 79 degrees. Okay, now the second one is 10 and 180. So let's go, this magnitude is 10 and the direction is 180. And you notice right here we have the resultant, which is what we had back over here. As far as in our work, we had a negative 1.032 and a 46.136. And we got that as far as our resultant is concerned right here. Oops, let me highlight it in green. Okay, and then if you notice, we got our magnitude right here was 46.148. That's what we got right here. And then last but not least, our directional angle was 91.281, which is what we got right here. So this is not to be in place of your work, because we're going to grade work, but it is a good way to check your work to make sure that you did in fact do the correct steps. Let's look at B. To make the field go, the resultant force of the kick and the wind actually should have a magnitude of 50 miles per hour. So we're saying the resultant must be with a magnitude of 50 miles an hour, and the direction is 85. Okay, so let's come over here, and we're going to say this time that our resultant, which we can say is K plus wind, that the magnitude is 50 miles an hour, and that the direction should be 85 degrees. So to counteract the 10 mile per hour wind, so W for wind, and it's 10 miles an hour, with what speed and what direction should the football player kick the ball? So we know that this wind, again, is coming from the right and it's going to the left, so it's traveling at 180 degrees. This one is not a vector addition, this is a vector subtraction, which the program that I built does not do. It just does vector addition. So we have to know how to definitely do this, because we won't have the program to check our work per se. So let's get the resultant components, which are going to be right here, okay? And we're going to do that like normal by doing 50 times the cosine of 85. So we'll say 50 times the cosine of 85, and we'll do 50 times the sine of 85. And we get the following components: 4.358. So we'll say 4.358, and then the y component was 49.809, but that's going to round up, so 49.810. Okay, we're going to do the same with the wind, and I'm going to borrow with what we did last slide with that 0 and 180 to be negative 10 and 0. And now we're trying to find the kicker. Okay, we're trying to find what should the speed be, which is the magnitude, and what should the direction be, which is the angle right here. So because we're going backwards, we know already that K plus W is the resultant. Therefore, the resultant minus the wind is K. So what I'm trying to do is I'm trying to show that the resultant vector, which we have here, if I write it out, 4.358, okay, 4.358, and then 49.810, this is R, and then W is this negative 10, 0. And what I'm going to do, and let me highlight it, I'm going to subtract these two. Okay, so it will look like this. 4.358 minus a negative, which is the same as adding, will give me a 14.358. And then it's just 49 minus 0. That one doesn't change. And now you're ready to work backwards from this by doing the arctangent and doing the magnitude for those pieces. So let's do the magnitude first, right here. The magnitude is taking the square root of the squares of each piece. Okay, so let's go ahead and do that in the calculator. So we'll say the square root of parentheses, and it's going to be that 14.358. So 14.358 squared plus parentheses the 49.810. 49.810 squared. And we get the answer of 51.838. So that goes right here, 51.838 miles per hour. Since miles per hour is in fact our units of measure. Okay, so now we're going to do the arctangent. We're going to see what we get there. We're going to do the arctangent of this vector, which is 49.810 over 14.358. Now, it's very important that you look at the signs. This is a positive 14, this is a positive 49. So it's basically going to say it's positive, positive, showing that it will result in a quadrant 1 of some sort respect. Okay, so again, quadrant 1 and 4, I'm not going to add anything to this angle that I get from right here. So let's see what we get if we put this into the calculator. We're going to do the arctangent, of control divide, and it's going to be the y value over the x, which was 49.810, and it's going to be over 14.358. And I get 73.920. So 73.920 degrees. And again, I'm not going to do anything with that because it's in quadrant 1 or 4. It's just going to be exactly what you see. Okay? So we're going to say the player should kick the ball at an angle. So let's write it out. The player should, based off of what this problem is saying, kick the ball at an angle of, we'll say theta equals 73.920 degrees at 51.8, what did we get over here? 51.838 miles per hour, which means that's what will make the goal actually happen.